what we see happening here is a trend reversal. That's what this candle means, right? It's a gravestone doji candle. It's typically found at the tops of rallies, and it spells trend reversal. Now, does this mean tomorrow there's going to be a trend reversal or the day after? No. In the bigger picture, trend reversal.
This is a pattern which was developing over the last 2 years. And what if I told you that right now, in that exact moment, after the breakout, we predicted
the Bitcoin ETF announcement, which occurred on the 10th of January 2024. So that's a 10-10 date, because 01 is also as above so below. So 10-10, we can see here 10-10 on the Phoenix. The Phoenix, as you know, is 91 in Chaldean. 9 plus 1 equals 10, right? So of course it was released on a 10 date. So this proves that the Phoenix is clearly referring to Bitcoin.
Welcome to Bitcoin faculty. I hope you are ready because today we're going to be finishing our basics on Python. So that means we're going to be doing dictionaries, modules, and packages. So let me share my screen with you. Right, so this is how far we've come. Super excited. I will also be looking at getting or taking the test and getting a certificate in Python. But for now, we've actually managed to learn a lot. So let's see what we have in store for us today. Just want to make sure, yep, my mic's working. Okay. So we are on learnpython.org if you would like to follow along as well. It's basically a free website where you can learn quite a bit on Python from beginner to advanced. We are doing this for programming in Bitcoin, just to serve as our foundation. So let's take a look at dictionaries. I just want to wait for the code to load up. I will put timestamps in all my videos. So, you know, like me, then you can skip whatever bits that you feel that you need to. Just want to load this again. Okay, usually works the third time round. Third time lucky. Okay. Let's not waste any time and go straight in. A dictionary is a data type similar to arrays, but it works with keys and values instead of indexes. Each value stored in a dictionary can be accessed using a key. which is any type of object, a string, a number, a list, instead of using its index to address it. For example, a database of phone numbers could be stored using a dictionary like this. So it looks like we define a dictionary using the curly brackets. So we have our variable name, our equal, and then curly brackets. And then it looks like when we want to create a database, we will refer to the name of our variable. And then, for example, John's number, which is here in square brackets as a string, will equal, and then it gives you the numbers. So let's see what happens if we print the phone book. Okay, and it's printed John's number, Jill's number, and Jack's number. It seems to be following. I wonder why it didn't do it in the order that we listed here. So we haven't done arrays yet, but we did do lists. If I can find over here in my ChatGPT just to revise, could be here, where we learned about the modulo operator. So we've become quite used to the modulo operator. We can see how it can help us to sort out numbers. For example, if we want to exclude even numbers or odd numbers, and we also came across its usefulness in hexadecimals. I want to see if I can find list. So it was not that one. Just bear with me, guys. ChatGPT gave quite a good summary of lists and arrays. I could just ask ChatGPT again. Can you explain to me simply the difference between lists and arrays? So lists are flexible. Lists store different items of different types. So for example, a list can have numbers and strings. Lists can grow and shrink in size automatically when you add or remove items. And also in Python, lists are a built-in data structure and are very easy to use. Arrays typically store items of the same type. In many programming languages, all elements in an array must be of the same type. So in other words, you can't mix numbers and strings. In some languages, arrays have a fixed size once they are created. However, in Python, arrays from the array module can be resized. Arrays can be more memory efficient and faster for certain operations compared to lists. In Python, to use arrays, you often need to import a module like array or use libraries like NumPy. So we will get to NumPy arrays. In fact, it's the section after dictionaries and modules and packages. So just to refresh you, a dictionary is a data type similar to arrays, but works with keys and values instead of indexes. So remember when we worked with lists, we learned how each element in a list has an index. And we learned that that index always starts at 0. So if you want to print item or element number 3 in a list, it will actually be element number 2 because it counts from 0, not 1. So it would be 0, 1, 2. So a dictionary works with keys and values instead of indexes. Each value stored in a dictionary can be accessed using a key, which is any type of object, instead of using its index to address it. So we've seen this example here of a phone book, but we also see here that a dictionary can be initialized with the same values in the following notation. So you will notice that in this example, where the curly brackets were empty, and then we used phone book, and then in square brackets, we put in our string John. Well, we can actually put the values within a dictionary inside the brackets. Don't forget our Python syntax and indentation. So notice here how John starts in a new line and it's indented. So we should get the same result if we print. And this time notice that it's in order. So John, Jack, Jill, instead of this example where even though we said in the order of John, Jack, Jill, it printed John, then Jill, then Jack. Dictionaries can be iterated over, just like a list. However, a dictionary, unlike a list, does not keep the order of the values stored in it. To iterate over key value pairs, we use the following syntax. So here's an example of phone book. We've initialized our data within the curly brackets, and then it says for name, so this is a loop. So remember when we talk about iterating, it looks like we're talking about our loops. So running code over a sequence of elements or data a repeated number of times until something happens. So for name, number in phone book dot items. So notice how phone book dot items, there's nothing in those brackets. It looks to be like a function print phone number of, then we've got our, to format our string, %s for the string, is %d for the decimal, and then of course we define our tuple with name and number. So if we run this code, you can see here it prints that phone number of Jill is, and then it gives us the numbers and so on. So this is a loop, and basically it will iterate over each element or item in the dictionary till, well, basically until in this case it got to the third item. To remove a specified index, use either one of the following notations. So we have here our phone book, we've initialized it. Now we can use del to basically delete John from the list. So if we say del phone book square brackets John, it should now only print Jack and Jill. Yeah, so we have Jill and then we have Jack. And I just want to show you here the way we initialize. So it seems like within a dictionary, I could be mistaken. I will verify this, but these are like our keys, right? And after we've chosen like our key name, we use a colon and then we put in our value. So we've done remove a value. Here's another way of removing a value, and that is to use pop. So you would say phone book dot pop and then the key of the dictionary that you want to delete. So I'm definitely going to get some clarity on this now from ChatGPT. So let's start with the following. Let's get a new chat. In this line of code are the names. So it's Python example of a dictionary are the names, in this case, John, Jack, and Jill, the keys and the numbers, the values. Can you paste our code? So that is correct. In the given line of code, the names John, Jack, and Jill are the keys, and the corresponding numbers are the values. Here's how the code works. When you print the phone book dictionary, it will output John, Jack, Jill. In this dictionary, John, Jack, and Jill are the keys, and then the numbers are the values associated with those keys. So I can't really compare it to an array at this stage. I'm not too familiar with arrays. But if we think of a list which just has elements, there's no, if we compare it, it's more like if we have a list, phone book underscore names, and then we have our list, and we could just have John, and we separate it by commas. You can see in dictionary, we're not separating any elements with commas. We have John, Jack, Jill. Well, these are just really like one-sided elements. There's nothing more to these elements other than the string. And that string is determined by the point within this index. So John is 0, Jack is 1, Jill is 2. So it looks like with the dictionary, the key distinction of what sets it apart from from lists and arrays is that we have a key and we have a value. And each value stored in a dictionary, so think of this here, these numbers, can be accessed using a key. So that's the example that they gave us here, where we were able to, just by calling on the key John, we were able to access the value and delete it. We didn't have to say John and then input the whole number. We just had to call on the key of John. And again, just to emphasize that every value stored in a dictionary, which is accessed using a key, is basically any type of object. So in other words, it can be a string, a number. We're quite familiar with those two. It can even be a list. So within John, maybe John has 2 numbers then let's see what happens if we make John as a list. So 8, I'm just going to make up numbers, and then let's close our list and let's see what happens. So actually dictionaries can be quite complex in that they can handle lots of different types of objects within Python. And we don't need to access it using the index, which we saw can get quite tricky with the 0 just in there to complicate matters. Now we just need the key. So we have 2 examples here of how to basically add keys and values to a dictionary. The one is this way. So in this case, the phone book is empty, but then using the name of the dictionary and the square brackets, and then followed by equals, we're able to add a key and a value. But the other way, which is within the curly brackets, is we, for example, in this case, we put our string, which is our key, we use our colon, and then anything that's after the colon is basically a value that gets assigned to that key. For iterating over dictionaries, dictionary, unlike a list, does not keep the order of the values stored in it. To iterate over key value pairs, use the following syntax. So I'm going to ask ChatGPT to explain that. Can you explain this example to me in full? And then let's just print the code. Okay, so the first step is creating a dictionary. The dictionary is called phone book, and it's got 3 key value pairs. The keys are the names John, Jack, and Jill, and the values are their respective phone numbers. Iterating over the dictionary. In this part, we use a for loop to iterate over the key value pairs in the phone book dictionary. Let's break down the syntax used. Phonebook.items with the round brackets, it's basically got no arguments inside of it, but this method returns a view object that displays a list of a dictionary's key value tuple pairs. For the phone book dictionary, it would look like this. For name, number in phone book items, the loop iterates over each key value pair in the dictionary. In each iteration, name is assigned the key and number is assigned the value. Okay, we understand the print function and how to format strings. So, key points, dictionary and iteration. A dictionary can be iterated over just like a list, but it does not maintain the order of elements. .items method. This method returns key value pairs from the dictionary. And then we know about string formatting. So I'll just ask it, so will .items always be used to return key value pairs from any dictionary that is created? Yes, the .items method, the .items method is a standard way to return key value pairs from any dictionary in Python. When you call .items on a dictionary, it returns a view object that displays a list of the dictionary's key value tuple pairs. This method is very useful when you want to iterate over both keys and values. See. Here's a summary of different methods to iterate over a dictionary and when to use them. So for key in dictionary, print key. Or for key in dictionary.keys, print key. For value in dictionary.values, print value. For key value in dictionary.items, print, okay, example. Let's see an example with a sample dictionary. So we have a sample dictionary created here. We've created the keys and the values within the curly brackets. So if we want to iterate over the keys, print keys. For key in sample dictionary.keys, print key. And if we want to print the values, okay, we've already done that. So I'm going to take some notes on this for you guys, but we've got .keys, which returns a view object displaying a list of all the keys. We've got .values, which returns a view object displaying a list of all the values in the dictionary. And then we've got .items, which returns a view object displaying a list of the dictionary's key value tuple pairs, which is useful for iterating over both keys and values. So .items is indeed the method you would use whenever you need to access both keys and values while iterating over a dictionary. This is important for us to know because, like, for example, Learn Python is not actually demonstrating those other tools for us. So we can try that. We can say, we would say for key, yeah, for for key in phone book dot keys. I think it's 2 S's, plural keys. Yeah. Let's print key. Yeah. So let's run that and see. We should get just the names. For key in phonebook.keys, too many values to unpack. So let's say I'm getting this error when I run .keys. So it doesn't want to copy. Try again though. So value error. Nope. So basically the error is that it's value error. Too many values to unpack. Value error. Too many values to unpack. error, too many values to unpack, occurs when the number of variables on the left side of the assignment does not match the number of values provided. This error is commonly encountered when incorrectly unpacking elements in a loop, particularly when iterating over a dictionary. To clarify, here's an example when the error might occur and the correct way to use doc keys. If you try to unpack the keys directly using two variables, for key value in, this is interesting. This will result in a value area. So we're looking at this example over here. Because phonebook.keys returns only the keys, but you are attempting to unpack them into two variables, key and value. Gotcha, key and value. Well, that's not really what I was trying to do here. Let's go on. To correctly iterate over the keys values and key value pairs, use the appropriate methods without mismatched unpacking. So for key in phonebook, print key. For key in phonebook, I've done that. Keys is not defined. Let's try and run it again. Oh, it worked. I don't know why it didn't want to work before. Basically, what's happening here, so I'm actually understanding the dot items method now. Because do you notice here, remember when we use dot items, we are taking the key and the value. So do you notice when we do our for loop, we've got name and number in phonebook dot items. So just by trying to understand that error, we can actually understand this code better. Because if we take out number, it won't work. And it's giving us that error because it's expecting two outcomes, if that makes sense. It's expecting to print John and the number, Jack and the number. But now we're only limiting it to name because we're using the dot items. What do you call it? Method? Okay, so I'm going to put for name number in phonebook. Okay, so don't stress. I'm going to make notes so that we can remember the dot keys, the dot items, and the, I would think, dot values. Let's just see here. Dot values. Yeah, dot values. So should we try for value, oops, for value in phonebook dot values, then we're going to print, this here. We're going to print value. So we should just get the numbers now. And that's what happened. So now we know how to use dot keys and dot values. I will also make a note of this using del or del for delete to remove a value, and also the dot pop method to remove basically a key. When I say value, I actually mean an object. These are actually objects. John, the string John with the number, is an object within the dictionary. There was one thing here. What do you mean by a dictionary's key value tuple pairs? So we've learned about tuples already a little bit. A dictionary's key value tuple pairs refer to the structure of data that is returned when you use the .items method on a dictionary in Python. Let's break down what this means. A dictionary in Python is a collection of key value pairs. Each key in the dictionary is unique, and it is associated with a specific value. When you call the .items method on a dictionary, it returns a view object that displays a list of tuples. Each tuple in this list represents a key value pair from the dictionary. A tuple in Python is an immutable ordered collection of elements. It is represented by parentheses, brackets, and can contain multiple values separated by commas. For example, key, comma, value is a tuple containing a key value pair from a dictionary. So we learned about tuples when we were formatting our strings. And we use, and even don't forget our hexadecimals, when we use %s, %d, %x for hexadecimals, and there was even percentage, I think it was f for decimals. I'll have to double check that. And what you do is you basically put that percentage within your string, and then later on in your tuple, so after your string and after you've closed your inverted commas, then within your tuple you put in either the specific values or the specific values like a number or a string, or you can put in a variable name as long as you define that variable at a stage. So let's go back to our phone book example. When you call phonebook.items, it returns a view object containing key value tuple pairs. Each tuple in this list represents a key value pair. John, the string, and then number, is a key value pair when John is the key and that number that you see there is the value. So when we talk about a dictionary's key value tuple pairs, we are referring to the tuples that represent the individual key value pairs in the dictionary, typically returned by the .items method for iteration or processing. Then there was something else. So it's been 40 minutes. We're going to take a break, and then I will basically just get a summary for dictionaries on us. What are the advantages of dictionaries? In what context is it used? Because it's great that we're learning about all these different types of tools. Like we've learned about functions, we've learned about lists, we've learned yeah, we've learned quite a bit, but I would like to know why are dictionaries important? I can see the benefits because of the different types of objects you can place in them, but we're going to take a look at that and then we're going to do our exercise. I hope you guys enjoy the video that I've created for you. It's actually just one snippet of the video, and I'll be releasing more as we go along this week.
What we see happening here is a trend reversal. That's what this candle means, right? It's a gravestone doji candle. It's typically found at the tops of rallies, and it spells trend reversal. Now, does this mean tomorrow there's going to be a trend reversal or the day after? No. In the bigger picture, trend reversal.
This is a pattern which was developing over the last 2 years. And what if I told you that right now, in that exact moment, after the breakout, we predicted
the Bitcoin ETF announcement, which occurred on the 10th of January 2024. So that's a 10-10 date, because 01 is also as above so below. So 10-10, we can see here 10-10 on the Phoenix. The Phoenix, as you know, is 91 in Chaldean. 9 plus 1 equals 10, right? So of course it was released on a 10 date. So this proves that the Phoenix is clearly referring to Bitcoin.
Bye.
let's resume. So we said we were going to just get a bit more information about dictionaries and the functionality. So can you explain for me the concept of dictionaries in Python, why they are useful compared to other tools in Python and their use cases. Dictionaries in Python are data structures that store key value pairs. They are unordered, mutable, in other words modifiable, and can contain any type of data, strings, integers, lists, and even other dictionaries. Dictionaries are defined using curly braces, and each key value pair is separated by a colon. And then they've got an example here, but we've looked at a couple of those already. This example has a list within the dictionary. Why are dictionaries useful? One is for fast lookups. Dictionaries use hash tables internally, making lookups for keys very fast. Flexibility. Dictionaries can store a wide range of data types as values, including other dictionaries, lists, tuples, etc. Uniqueness of keys. Keys in a dictionary must be unique, making them suitable for scenarios where you need to map unique identifiers to values. Mutable. Dictionaries can be modified, allowing you to add, update, or remove key value pairs dynamically. Efficient data organization. Dictionaries provide a convenient way to organize and access data based on meaningful keys rather than relying on numerical indices. For example, like in lists, where we use our indexes. Use cases for dictionaries. One is for mapping data. Dictionaries are commonly used to map keys to values. For example, a dictionary can store information about students, where the keys are student IDs and the values are their names, grades, and other details. Two is configuration settings. Dictionaries are useful for storing configuration settings in applications. Each setting can be a key value pair, making it easy to access and modify settings as needed. 3. Database-like operations. Dictionaries can mimic database operations where keys represent unique identifiers, for example, user IDs, and values represent corresponding data, for example, user profiles. So probably like your Facebook, your Twitter. Counting and frequency analysis. Dictionaries are useful for counting occurrences of elements in a collection. For example, counting the frequency of words in a text can be done using a dictionary where keys are words and values are their counts. JSON-like structures. Dictionaries in Python are similar to JSON, JavaScript object notation, structures, making them useful for working with JSON data in Python applications. Overall, dictionaries are versatile and powerful data structures in Python that provide efficient mapping and storage capabilities, making them indispensable for a wide range of programming tasks. I'm curious here, does Bitcoin make extensive use of dictionaries? So on this channel, we're not learning Python just for the fun of it. We are learning Python for Bitcoin. So let's see. Okay, so the answer is basically no. However, let's have a read through it. Bitcoin, being a decentralized digital currency system, we're going to get into that later on in a lot more detail, primarily relies on cryptographic principles, data structures, and algorithms specific to blockchain technology, while dictionaries in Python or similar data structures in other programming languages are powerful tools for organizing data. They are not directly used in the core implementation of Bitcoin's blockchain protocol. The key structure in Bitcoin is the blockchain itself, which is a chain of blocks containing transaction data. Each block in the blockchain contains a header and a list of transactions. The header includes various fields such as the block's timestamp, a reference to the previous block's hash, the Merkle root of transactions in the block, and other metadata. However, it's worth noting that when developers work on software applications or tools related to Bitcoin, they may use dictionaries or similar data structures for managing various aspects of the system. For example, transaction inputs and outputs. In Bitcoin transactions, inputs spend outputs from previous transactions. These inputs and outputs can be organized and managed using data-like structures, like dictionaries or maps. Wallet software. Wallet software for managing Bitcoin addresses, private keys, and transaction history may use dictionaries or other data structures internally to organize and access this information efficiently. Blockchain analysis tools. Tools that analyze the Bitcoin blockchain, such as block explorers or analytics platforms, often use data structures like dictionaries to store and retrieve data related to blocks, transactions, addresses, and more. So I didn't know that. And then scripting and smart contracts. Bitcoin's scripting language allows for some level of programmability, enabling the creation of simple smart contracts. While not exactly like dictionaries, data structures and logic similar to dictionaries can be used in scripting scenarios within Bitcoin. In summary, while Bitcoin's core protocol and blockchain implementation do not rely on dictionaries in the same way as software applications might, developers working on Bitcoin-related projects may use dictionaries or similar data structures as part of their tooling, software interfaces, or analysis systems. I'm quite happy with the progress that we have made on our dictionaries. So let's head over to the exercise. So what we need to do is we need to add Jake to the phone book with the phone number and remove Jill from the phone book. So I think we need to ask ChatGPT, how would we add a key value pair to a dictionary? I know how we can remove it using pop. Let's just see here. You can add a key value pair to a dictionary in Python using the following syntax. So I think we actually did see it in the example up at the top here, where phone book was initially empty, and then what we do is we call on the phone book name, and then in our square brackets we do what we need to do. So we would say phone book square brackets, and we need to add Jake. Remember, it's a string, and then we're going to say equal. So it's 938273443. Then we need to remove Jill from the phone book. So I think we would say phone book dot pop, and then I think we use round brackets, and we are going to remove Jill. So let's just double check that. Yeah, phone book dot pop. So let's submit. And the way that we're going to test this code is that if Jake is in phone book, meaning, remember this is an if-else statement, there's no else, but it's basically going to return a Boolean value, so true or false. So it's going to check if this is true, if Jake is in the phone book, which is what we've tried to do over here. And if it is, it will print that Jake is listed in the phone book. And then to test the second part of the code, it's using a similar logic. If Jill not in phone book, print Jill is not listed in the phone book. So we should be able to print these two statements. And we got it correct. So it printed out both were true. It printed out Jake is not listed in the phone book and Jill is not listed in the phone book. Let's now do some notes on dictionaries. Okay, so we have learned that dictionaries is basically, it works with key value pairs. Okay, it uses this instead of indexes. So before, when we wanted to get an item from a list, we would have to refer to the index. For example, we would say phone book and then, phone book and then the brackets and whatever element you wanted to print from the phone book. Now we can access it using a key. But what's great about dictionaries is they can actually hold basically any type of object. So not only numbers and strings, which we're used to, but other lists and even other dictionaries. So the way that we create a dictionary is we have, for example, phone book, which will be the name of our dictionary. And then what we do, we say equal. Now remember with a list, we would use square brackets. Well, now we're going to use curly brackets for a dictionary. You can input your information directly in here, or you can simply add the information that you want underneath. So you would say phone book. Now we're going to use square brackets. Our key is going to be John, and the value that we're going to assign to our key John is 0589, and so on. So that's how we can quite easily insert a key pair into a dictionary. We use this syntax here. I will show you now how to do it within a dictionary. The other way of doing it, for example, we would say phone book equals, and now we can actually start putting in our keys and our values. So now we will say John, but now we'll put a colon and then we'll put our value. And you keep going, and then when you want to close it, you just end off with a curly bracket. But you can still at any point after this add another key pair using the method that I just showed you. Then we learned about iterating over dictionaries. So let me just find that. So remember, this is our key and this is our value. So to do the different iterations, we have dot keys. Let me open a new page here. So we have dot keys. This is very thick. Dot keys. No, this looks terrible. Menu new. Let's just try that again. Remember, first of all, when we talk about iterate, we are talking about our loops. Okay, so we have for and while. But remember, when we looping over a specific range, for example, like a list or dictionary, we use the for loop. Okay. So we have dot keys. We have dot values. And we have dot items. So we know what our keys are and we know what our values are. So I just showed them on the previous slide. And this would just print the keys like John. Or under values, the number. When we use dot items, then we're printing the string, sorry, the key and the value. And the way that we do it is we use the for loop, like I said. And in the example, we're using the items. So we want two things, the name and the value. So we say for name value in phone book, and we would say phone book, this is where we bring in our syntax over here, phone book dot item. So now it's expecting two things because we're using dot items, expecting a key and a value. Then what we will do is we can just print. Sorry. We can print, and then in the example they gave us, it printed a string. I'm curious to see if we try this. So if we say for name, let me switch over. If we say for name number in phone book dot items, okay, we want to just print, maybe we don't want to print a string, we just want to print the key and the value. Let's see if this will work. I'm actually not sure. Yes, so you can see here it's done that, I think. I don't think it has. Print. Alright, so I'm just looking at it in the wrong order. So this is the values, that's the keys. Yes, so it's worked. You see here how it's printed name and number. So let's just go back to our notes. So we use the keys to display the keys in a dictionary. We use the values to display the values in a dictionary. And we use the items to iterate over both the keys and the values. So now we also learned, so we know how to add a key pair to a dictionary. Let's take a look at removing. So in order to remove a key pair from a dictionary, we use dot pop. I personally find that easy to remember. So for example, we know about our dictionary phone book and we just say dot pop. And now instead of like in the case of a list, where you have to refer to the index that the element is in that you want to remove, all we have to do in this case is specify the name of the key. So it was John that we wanted to remove, and it will remove both the key and the value. But there's also another way if we use delete. So if we say del space phone book, and then we just simply put John, but this time we're going to use square brackets. And then what it will do is it will remove John. Now, maybe you'll find this method easier to remember because we use square brackets when we're adding. So we would say phone book square brackets still equals, and maybe that's just easier for you to remember than how to remove it. We just use del, the name of the dictionary, and then your square brackets again. So that's all dependent on your preference. If we don't use the right syntax, we're going to end up with errors. So that is the thing. Okay, so we are ready to move on to our last exercise in the basics of Python. If you've made it this far, well done, really. I know it's not easy. Hopefully going through it together though does make it easier. So I'm just waiting for that to load. It's still loading. So last one for this, basics, modules, and packages. Okay. In programming, a module is a piece of software that has a specific functionality. For example, when building a ping pong game, one module may be responsible for the game logic, and another module draws the game on the screen. Each module consists of a different file which may be edited differently. Modules in Python are just Python files with a .py extension. The name of the module is the same as the file name. A Python module can have a set of functions, classes, or variables defined and implemented. The example above includes two files. So it's still loading. I'm just going to try and refresh this. So in the example, we have two files. We have my game, and then we have game.py, and then we have draw.py. The Python script game.py implements the game. It uses the function drawGame from the file draw.py, or in other words, the draw module that implements the logic for drawing the game on the screen. Modules are imported from other modules using the import command. In this example, the game.py script may look something like this. So the way I understand it, but I stand to be corrected, is like when you actually, so at the moment we're working on the web, on the internet site, learnpython.org, but when we work in our actual software, which is for writing code in Python, you can have different files within one project. So, for example, when you're writing code in JavaScript, or in fact anything probably, when you have, for example, your HTML file, which is going to be your website, you don't necessarily want to mix all of that code in one file, if that makes sense. So you want your HTML file to be separate. So then there's a way that you link the files together so that they all draw on each other. I think that kind of explains it, but I'm going to read on. So we have import draw. And then we have def. Def was for functions. Right. No module named draw. The draw module may look something like this. Okay, we are sharing the screen. In this example, the game module imports the draw module, which enables it to use functions implemented in that module. The main function uses the local function playGame to run the game, and then draws the results of the game using a function implemented in the draw module called drawGame. To use the function drawGame from the we need to specify in which module the function is implemented using the dot operator. To reference the drawGame function from the game module, we need to import the draw module and then call drawGame. When the import draw directive runs, the Python interpreter looks for a file in the directory in which the script was executed with the module name and a .py suffix. So you'll see that suffix or the end bit of the file name is quite important. In this case, it will look for draw.py. If it is found, it will be imported. If it is not found, it will continue looking for built-in modules. You may have noticed that when importing a module, a .pyc file is created. This is a compiled Python file. Python compiles files into Python bytecode so that it won't have to parse the files each time modules are loaded. If a .pyc file exists, it gets loaded instead of the .py file. This process is transparent to the user. A namespace is a system where every object is named and can be accessed in Python. We import the function drawGame into the main script's namespace by using the from command. And then I see we can also use the import command to import all the objects in a module. This might be a bit risky. Okay, custom import name. Modules can be loaded under any name you want. This is useful when importing a module conditionally to use the same name in the rest of the code. For example, if you have to draw modules with slightly different names, you may do the following. Okay, module initialization. The first time a module is loaded into a running Python script, it is initialized by executing the code in the module once. If another module in your code imports the same module again, it will not be loaded again. So local variables inside the module act as a singleton, meaning they are initiated or initialized only once. You can then use this to initialize objects. This is quite complex. There are a couple of ways to tell the Python interpreter where to look for modules, aside from the default local directory and built-in modules. You can use the environment variable Python path to specify additional directories to look for modules like this. Okay. And I see they've got some built-in modules. Check out the full list of built-in modules in the Python standard library here. Two very important functions come in handy when exploring modules in Python: the dir, and help functions. To import the module urllib, which enables us to create read data from URLs, we import the module. So we import urllib, and then to use it, we say urllib.url open. So let's see what happens if I run that. We can look for which functions are implemented in each module by using the dir function. Import urllib and then dir square brackets and then the name of the library. When we find the function in the module we want to use, we can read more about it with the help function using the Python interpreter. For example, URL open, we want help on it here. Writing packages. Packages are namespaces containing multiple packages and modules. They're just like directories. They're just directories but with certain requirements. Each package in Python is a directory which must contain a special file called init.py. This file, which can be empty, indicates that the directory it's in is a Python package. That way, it can be imported the same way as a module. If we create a directory called foo, which marks the package name, we can then create a module inside that package called bar. Then we add the init.py file inside the foo directory. To use the module bar, we can import it in two ways. Okay. In the first example above, we have to use the foo prefix whenever we access the module bar. In the second example, we don't, because we've imported the module to our module's namespace. The init.py file can also decide which modules the package exports as the API while keeping other modules internal by overriding the all variable, like so. In this exercise, print an alphabetically sorted list of all the functions in the re module containing the word find. That is hectic. So I'm definitely gonna need some assistance here. A lot of this stuff sounds pretty complicated to me. I feel like even though it's geared towards beginner coders, the explanations aren't always the greatest. We have, however, run into our second 40 minutes time frame. So I will now be taking another 10-minute break and then we will resume. We will be finishing modules today. It is modules and packages. Let's see how we can actually get to understanding this, even if it is at a basic level for now. I'll see you guys in 10 minutes.
What we see happening here is a trend reversal. That's what this candle means, right? It's a gravestone doji candle. It's typically found at the tops of rallies, and it spells trend reversal. Now, does this mean tomorrow there's going to be a trend reversal or the day after? No. In the bigger picture, trend reversal.
This is a pattern which was developing over the last 2 years. And what if I told you that right now, in that exact moment, after the breakout, we predicted
the Bitcoin ETF announcement, which occurred on the 10th of January 2024. So that's a 10-10 date, because 01 is also as above so below. So 10-10, we can see here 10-10 on the Phoenix. The Phoenix, as you know, is 91 in Chaldean. 9 plus 1 equals 10, right? So of course it was released on a 10 date. So this proves that the Phoenix is clearly referring to Bitcoin.
we're back from our break. Let us resume with modules. From what I can tell here, this is very much theoretical. So I'm going to ask ChatGPT just to help us out a bit here. And I'm going to say, I am a beginner in Python and I'm finding the concept of modules difficult to understand. And explain the following to me simple terms. And then I'm going to also copy over the code. What is a module in Python? In programming, a module is like a toolkit that contains specific tools or functionalities that can be used in a program. For example, imagine you're building a ping pong game. One module, a Python file, remember I talked about different files, might handle the game's logic, while another module might handle drawing the game on the screen. Each module focuses on a specific aspect of the program. So rather than having your programming all in one file, which can be difficult and also quite long to read, you would have it in separate files. Writing modules in Python. A Python module is simply a Python file with a .py extension. The module's name is the same as the file name without the extension. For example, if you have a module named game.py, its file name would be game.py. So basically the name of the file is game. Content of modules. Modules can contain functions, classes, variables, or any code that implements specific functionality. In your example, you have two files in a directory named mygame, and they are game.py and draw.py. Game.py implements the game's logic, while draw.py implements the logic for drawing the game on the screen. Modules are imported into other modules using the import command. In your example game.py, it imports the draw module using import draw. So remember, that's where the names of our files come into play. So the names of our files are effectively draw and game. So you wouldn't say import draw.py, you just say import draw. So in this code, which is basically the example we have over here, we import the draw module using import draw. We define functions for the game logic and the main entry points. So this is play game. That's where the game logic would go. And then we have the main entry points. Okay. And then we use the draw module to draw the game. So draw game. Inside main, we play the game, which is play_game. So that would be this here, result equals play game. And then use functions from the draw module to draw the game on the screen. So draw.drawGame results. Remember, result is this here. We've defined results within this function, which is play game. So we basically, inside main, we play the game and then use functions from the draw module to draw the game on the screen. So we're calling on the draw module that we imported, and then we say draw game, and then your result is this function over here, play game. By organizing code into modules, you can separate concerns, make code more reusable, and manage complexity in larger programs. Each module can be edited separately, making development and maintenance easier. So you can imagine, like in a real world example, where you have someone who's focusing on the drawing aspect and then someone who's actually focusing on the game logic. I just want some clarity here. In the example above, draw game is not defined. You're correct. In the example provided, draw game is used as an example function that would be defined in the draw.py module. Let me clarify this by providing a more complete example that includes the definition of draw game. Firstly, let's assume you have a draw.py module with the following content. So this is in our draw.py and it's draw game. So now I think I understand when we use the draw module, this is a function within the draw module, draw game. And remember, result points back to this play game. So you can see how we are incorporating the two modules. So let's move on. So I'm going to read again from learnpython.org. In this example, the gain module imports the draw module, which enables it to use functions implemented in that module. The main function uses the local function play game to run the game. So this is our main and this is play game. Okay. And then draws the results of the game using a function implemented in the draw module called draw game. So the result equals play game. And then we've got here within draw, the draw module, we can draw game. So it draws the result of the game. This is the result, which is here, draws the results of the game using a function implemented in the draw module called draw game. So it's actually essentially here that we've combined the two modules. To use the function draw game from the draw module, we need to specify in which module the function is implemented using the dot operator. So that's why we have draw dots. Okay. To reference the draw game function from the game module, we need to import the draw module and then call draw.drawGame. So we first import it over here, import draw, and then we call on a specific function using the dot. When the import draw directive runs, the Python interpreter looks for a file in the directory in which the script is executed with the module name and a .py suffix. In this case, it will look for draw.py. So remember here we're just using import draw, but it will look for draw.py. If it is found, it will be imported. If it is not found, it will continue looking for built-in modules. You may have noticed that when importing a module, a .pyc file is created. This is a compiled Python file. Python compiles files into a Python bytecode so that it won't have to parse the files each time the modules are loaded. If a .pyc file exists, it gets loaded instead of the .py file. This process is transparent to the user. So I'm also going to ask ChatGPT to explain that to us in simple terms. When you import a module in Python, a file with a .pyc extension may be created. This .pyc file is a compiled Python file. What does compiled mean? Compiled means that Python converts the human-readable code in the .py file into a form called bytecode, which is easier and faster for the computer to understand and execute. The bytecode is saved in the .pyc file. Why are .pyc files created? Python creates .pyc files to avoid reparsing the .py files every time you import a module. When you import a module, Python checks if a corresponding .pyc file exists. If it does, Python loads the bytecode from the .pyc file instead of parsing the .py file again. This process is transparent to users, meaning you don't need to do anything special. Python takes care of compiling and managing .pyc files behind the scenes to make the module loading faster. In simple terms, the creation of .pyc files helps speed up the loading of modules in Python by storing pre-processed bytecode, making the process more efficient for your programs. I'm just going to say what is meant by parsing in this context. In the context of programming and scripting languages like Python, parsing refers to the process of analyzing and interpreting code written in a human-readable format, such as Python code, into a form that the computer can understand and execute. Here's what it means in simpler terms. Human-readable code. When you write code in Python or any programming language, you write it in a way that is easy for humans to understand. This code contains instructions, functions, variables, and other elements that you use to create your program. Parsing to bytecode. Before your Python code can be executed by the computer, it needs to be translated into a form called bytecode. So remember we learned about bits and bytes when we did hexadecimals. So basically a byte is 8 bits, which is basically 1 bit is a 0 or a 1. So it's basically a combination of ones and zeros. So bytecode is a lower level representation of your code that the computer can understand and execute more efficiently. Because remember, computers ultimately use ones and zeros. The parsing process. When you run a Python script or import a module, Python goes through a process called parsing. During parsing, Python reads and analyzes your human-readable Python code line by line, checks for syntax errors, and converts it into bytecode. Creating .pyc files. As part of the parsing process, Python may also create .pyc files. These files contain the bytecode generated from your Python code. They are created to speed up the loading of modules in future executions of your program. Python checks if a corresponding .pyc file exists when importing a module and uses the bytecode from the .pyc file if available, avoiding the need to repass the .pyc file. So I think that makes sense now. So you don't want it when you import the module to keep passing it. The .pyc file does that for you, just to make the importing, I suppose, easier from a computer perspective. In summary, parsing, parsing in the context of Python involves translating your human-readable code into bytecode that the computer can execute. It's an essential step in the process of running Python programs and contributes to the efficiency of code execution. So from now on, if we see a .pyc file, then we know what that is and actually how important that is. This is Ginger. Hello. Okay, importing module objects to the current namespace. A namespace is a system where every object is named and can be accessed in Python. We import the function drawGame into the main script's namespace by using the from command. So from draw, which is a module, import drawGame. So I think that's where you just want to, I suppose, import a certain aspect of a module's code, but not necessarily the entire thing. Maybe you just, for that specific function or whatever you're trying to do in that game, you don't need the whole module. You just need a certain function in it. So I'm just going to check. Am I correct that in this example, rather than importing the entire module, we use from to import a specific function or object from a module. And I'm going to copy the code and the rest of the explanation. Yes, you are correct. In the example you provided, the from statement is used to import a specific function, drawGame in this case, from the draw module into the current namespace of the .game.py script. So let's just look at our example here again. Okay. When you use from module name import function name, you are importing only the specified function from the draw in this case. In your example, from draw import drawGame imports only the drawGame function from the draw module. A namespace in Python is like a container that holds names such as variable names, function names, class names, along with the objects they refer to. Each namespace is isolated, meaning you can have objects with the same name in different namespaces without conflict. I think this is where JavaScript differs from Python, because Python, because you can create a variable that's constant, and that can help actually by reducing errors. Because when you have a lot of code and even possibly multiple teams working on a project, you could by accident have the same variable or namespace, and then it could lead to a conflict. I don't see how namespace applies here. We haven't really created a variable. Draw game result. Except we have sort of here, we've created a function and it says here a namespace includes function names. So that's, I think, what I was trying to explain above in this example. We have our result, which is play game, and then we have draw game, which is results. So do you see how the two are interrelated here? We have play game, which is our existing module, which gives us our results, and in the draw game function, we draw on our results, keeping in mind that draw game is from the other module. The advantages of from import. One advantage of using a from import is that you don't have to use the module name draw every time you use the imported function. This can make your code more concise and readable. So now we've created a function, right, called main. Now we don't have to keep importing draw because the function does it automatically for us. For example, instead of writing draw.drawGameResult, you can directly write drawGameResult after using from draw import drawGame. Well, in other words, after using main. It's important to note that when you use from, I'm just going to say from, otherwise this just sounds very confusing. If there is already an object in the current namespace with the same name as, for example, draw game, it will be replaced by the imported function. This can lead to namespace conflicts if care is not taken. For example, if there was already a draw game function defined in game.py, importing draw game from draw would replace the existing draw game function in the namespace. Now we move on to custom import name. Modules may be loaded under any name you want. This is useful when importing a module conditionally to use the same name in the rest of the code. For example, if you have to draw two modules with slightly different names, you may do the following. So I also don't really understand this. Can you explain this? I'm hoping we're not going to run out of our free version of ChatGPT. In Python, you can load modules under any name you choose. This is handy when you want to conditionally import a module and use the same name for that module throughout the rest of your code. Imagine you have two modules named drawVisual and drawTextual, each providing slightly different functionality for drawing. Depending on a condition, let's say visual mode, you want to import and use one of these modules in your code. That's why we have an if-else statement. Depending on the value of visual mode, remember if it's true, then draw true or false, draw visual or draw textual will be imported and given the name draw. Oh, I see. Import draw visual as draw. So in this case, yeah, we're naming them both draw. This way, regardless of which module is imported, you can use draw.drawGame in the rest of your code without worrying about the specific module name. This approach is useful for switching between different implementations or behaviors based on conditions, providing flexibility and maintainability in your code. So I suppose a practical way of understanding that is, for example, in your visual mode, you don't want to be concerned when you're writing code later on this what the result will be, because it could be either one depending on the Boolean outcome, whether it's true or false. And so to make it simpler, we can name it draw, and then in the rest of our code, whatever the outcome is, we can just refer to it as draw. So I can definitely see the usefulness of that. Now we get to module initialization. The first time a module is loaded into a running Python script, it is initialized by executing the code in the module once. If another module in your code imports the same module again, it will not be loaded again. So you have a file, okay, and you draw on the module. Python executes the code in the module. Then you have another file and you want to use that module again. Basically what it's saying is it will not be loaded again. So local variables inside the module act as a singleton, meaning they are initialized only once. You can then use this to initialize objects. I'm also going to ask for an explanation. Can you explain this to me in simple terms? Okay. Okay, it's going to repeat a little bit, but I'm going to read it anyway. When you import a module into a running Python script for the first time, the code inside the module is executed once, which is called module initialization. If another part of your code imports the same module again, Python does not reload the module. Instead, it uses the already loaded module. This behavior makes local variables inside the module act like a singleton, meaning they are initialized only once and then reused. In this example, when you import draw.py for the first time, the code inside draw.py is executed, including the initialization of main screen as a singleton instance of the screen class. So we draw game. Let's carry on. If another part of your code imports draw.py again, Python does not re-execute the code inside draw.py. Instead, it uses the existing main screen object that was initialized during the first import. This allows you to have a single instance, main screen, that can be used across your program, maintaining its state and behavior consistently. You can use this pattern of module initialization to create and initialize objects, set up configurations, or perform one-time setup tasks that should not be repeated every time the module is imported. I still don't really understand from a practical perspective. So ChatGPT is going to give us an analogy. Imagine you have a toolbox, which is your module, with tools, functions, and variables inside it. When you first open the toolbox, you take out the tools and set them up on your workbench. In other words, you initialize them. From that point onward, whenever you need to use these tools, you just reach out for them on the workbench without going back to the toolbox. In Python, when you import a module for the first time, Python executes the code inside that module, which includes defining functions, classes, and initializing variables. This is like opening the toolbox and setting up your workbench with the tools. Once the module is imported and its code is executed, Python remembers that the module has been loaded. If you import the same module again later in your code or in another part of your program, Python does not re-execute the module's code. Instead, it uses the already loaded module, just like reaching for the tools on the workbench. So when a module is initialized, it's like setting up your tools for use. Subsequent imports of the same module reuse the initialized state, like reaching for the tools on the workbench without re-executing the module's code. This helps in efficient memory storage and ensures that local variables inside the module act as singletons, meaning they are initialized only once and then reused. Perhaps this is because, I don't know, variables can change, and so it always defaults to the initialized value. I'm going to move on. Extending module load path. There are a couple of ways to tell the Python interpreter where to look for modules, aside from the default local directory and built-in modules. You can use the environment variable Python path to specify additional directories to look for modules like this. So we have Python path equals /foo python game.py. This executes game.py and enables the script to load modules from the foo directory as well as the local directory. You may also use the sys.path.append function executed before running the import command. Now the foo directory has been added to the list of paths where modules are looked for. So I suppose this is where if you want to look for, like they say, modules in another path or directory. Can you also explain this to me in simple terms? Okay. Oops. Control C. When Python runs a script and needs to import modules, it looks for them in specific places by default, such as the local directory and built-in modules. However, you can tell Python to look for modules in additional directories by extending the module load path. So the Python path environment variable lets you specify additional directories where Python should look for modules. For example, if you set Python path to /foo, and I just want to see here. Python will also search for modules in the foo directory. When you run a Python script, Python will now also look for modules in the foo directory in addition to the local directory. And then we can also use the sys.path.append. In your Python code, you use the sys.path.append and then in brackets /foo. So that's this example over here, to add the foo directory to the list of paths where Python looks for modules. This is done before importing any modules. For example, import sys. After executing sys.path.append, Python will include the foo directory in its search path for modules. So when you import a module, Python will also check the foo directory for that module. In simple terms, extending the module load path, allows Python to find modules in directories other than the default one. You can do this using either the Python path environment variable or the sys.path.append function in your Python code. This is useful when you want to organize your modules in separate directories or use third-party modules from specific locations. Cool. Then we're going to explore built-in modules. Can you also explain this to me? So we are doing built-in modules. So there's a Python library. So it looks like this will show us how to access that. Importing a module. To use a built-in module like URL lib, you first import it into your Python script. So remember, when we're talking about built-in modules, it says here that there's a list of built-in modules in Python in the Python standard library. You can check that out. This is cool. Oh, I see they've even got cryptographic services. So we will use these libraries, obviously, to help us. Here's Internet Protocol. There's some development tools, debugging tools, awesome. Anyway, so we know we would use import just like when we import a module in a different file. And then we use the dir function. The dir function helps you explore which functions and attributes are available in a module. After importing URL lib, you can use dir brackets URL lib to see a list of functions and attributes implemented in the URL lib module. This will output a list of functions and attributes available in a URL lib module. The help function provides information about a specific function or attributes within a module. For example, if you want to learn more about the URL open function in the URL lib module, you can use help. And remember, we use the dots in the brackets. So this is our library or our module, and we're specifically looking for help on URL open. This will display detailed information about the URL open function, including its parameters, usage, and functionality. In summary, when exploring built-in modules in Python, use dir to list functions and attributes, and use help to get detailed information about a specific function or attribute within the module. These functions are handy for understanding what functionalities a module offers and how to use them effectively in your Python programs. I'm going to go back to our course. And now we are on packages. Can you explain this to me in simple terms? Packages. Okay. What is a package? A package in Python is like a container that holds multiple modules and other packages. It's basically a directory with some special requirements. To create a package, you make a directory and give it a meaningful name like foo, for example. Inside this foo directory, you can create a special file called init.py. This file is what makes Python recognize the directory as a package. Hectic. Adding modules to the package. Inside the foo package, you can add modules like bar.py. These modules contain your code and functionalities. The init.py file can also be empty, but it's necessary for Python to treat the foo directory as a package. After creating the package and modules, you can import them into your Python scripts. If you want to import the bar module from the foo package, you can do it in two ways. Import foo.bar. Keep in mind bar is the module. This way you use the foo prefix whenever accessing the bar module, or from foo import bar. This way you directly import bar into a script's namespace so you can use it without the foo prefix. The init.py file inside the package can also control which modules are part of the package's public API. For example, if you set all equals square brackets bar in init.py, only the bar module will be accessible when someone imports the package. Other modules can remain internal to the package. In simple terms, packages are like folders that hold Python files. The init.py file inside a package marks it as a package, and you can organize your code into modules within that package. This helps keep your code organized and allows you to control which parts of the package are visible to users of your code. So we've done modules, which are like folders, and then basically a package is what holds all the modules together in an organized way. But remember, it needs to have the init.py file for Python to mark it as a package. So there is an exercise here. We've got a re module, and it contains the word find. So I'm going to ask for the solution, and then we can just so there's a number of things like sorted is new. So that's how we would basically sort it in alphabetical order. We have find members, which equals, so the square brackets indicates a list. And we say for, this is now for loop, for member in DRR. DRR we covered at the top here. Yeah. Or was it could have been in our previous section. So we want to basically see what functions are implemented in the module re in this example. So we say find members, it's a list. Then we say for member in and then we look for within our module re, we basically wanted to be able to list all the functions that are within the module re. If find is in member, okay, so basically each element in that in re now is identified as member or member, then find members dot append member, and then it will print sorted find members dot append member. So I'm going to also just ask ChatGPT, understand a little bit. Can you fully explain this to Okay, importing the re module. So we import re. Okay. This is Python's built-in module for working with regular expressions. Then we initialize an empty list. That was find members. This line creates an empty list, find members. This list will be used to store the names of attributes and methods in the re module that contain the word find. So what we do is we loop through attributes and methods of the re module. So we say for member in, we draw on the methods and attributes of re using dir. And then we say if find in member, and then it will better explain this. So the dir re function returns a list of all attributes and methods available in the re module. The loop iterates over each item in the list. For each item, it checks if the substring find is present in the item's name. If it is, it adds the item to the find members list. Sorting and printing the list. After the loop, the find members contains all attributes and method names from the re module that have find in their names. The sorted function sorts this list alphabetically. Finally, the sorted list is printed to the console. In summary, the code snippet explores the re module and finds all attributes and method names that contain the substring find. It then sorts and prints these names. This can be useful for understanding what find-related functionalities are available in the re module for working with regular expressions. So now we know how to basically, we can use the dir function to be able to look for certain things within a library, and we can be specific. For example, find. Find members is, up until then it was an empty list. So now it basically puts those attributes in this list. My last question, why the dot append member? The dot append member line in the code snippet is used to add an item to the find members list. Let's break down why it's necessary in this context. The purpose of dot append member is to add each item. Oh, right. That's how we add items to a list. We use dot append. Is to add each item that meets the condition into the find members list. So remember, we can actually add or remove items from a list. Dot append basically adds to a list. So we append member if it has find within the directory re. And we're appending it to find members. So I'm quite satisfied that I understand that now. I'm going to do a quick summary. Okay. We have done it. We have finished off the basics of Python. We could definitely see how it did get harder along the way, but I'm quite satisfied we have a good foundation on the basics. That's without much practice, but the understanding is there. So just to summarize, in this last section of the video, we've dealt with modules and packages. Modules are basically a file within your code. So we name our modules with a .py extension, okay? And for example, each module will have different attributes or functionalities. So you might want to, if you have multiple people working on a project, or in the case of like even your HTML file, it's not necessary to include all of that in one file. You basically can break it up into modules. That's basically what modules are in a nutshell. We learned how we simply use import and then the name of the file, meaning the name of the file without the .py at the end. And what Python does is it then executes the code by importing that module. Then we also learned how to, from a specific module, we can draw in a specific object, for example, a function. And to do that, we say from. So we say from draw being our module name, import, and then whatever the name is of the function that we're looking for. We learned that this was useful because then when you create a function, after that, you're not necessarily having to repeat the names. Because now your function does that for you automatically. Okay, then we learned about being able to have a custom import name. So a custom import name, we used an if-else statement. So typically, if something happens, we want to import from this module, else we want to import from another module. But we add a bit at the end of those if-else statements, which is as draw in this example. So it doesn't have to be the word draw. Remember, draw is just the name of the module in this example. And what that does is both effectively become draw, but it makes it easier for coding later on, because whatever you code later on, you want to be able to refer to draw without being worried about what the outcome was, whether it was true or false, this module was incorporated, or that module was, the other module was imported. So that's where as becomes useful. We also learned about module initialization. So I'm just checking here. This was still a bit sketchy to me, but basically the first time that a module is loaded into a running Python script, it is initialized. And basically what happens is they are only initialized once. Okay. I'm not too worried about that. Then extending module load path. So that's where you want to import a module, say, from another directory, not your default directory. We learned that there's two methods to do that. There's Python path, and then there's sys.path.append. We also learned about, and we had a brief look at built-in modules. So you import it in the same way. And then we also, we learned about the usefulness of the dir and the help functions. So dir can help us to look at the functions that are implemented in a module, and then we can actually use help to get more information on that function within a specific module. And then lastly, we learned about packages. which is basically you have your folders or your modules, and your package is what holds all of them together. And we know that each package in Python is a directory which must contain a special file which is called init.py. So that is it for today. I would like to check here quickly. Now that we've covered all our basics, how long did this actually take us? So let's see. We had 1 hour there plus, so 3.5 hours, 4.5 hours, 7 hours, 10.5 hours, and then of course today's video, sorry, I left one out, so it was 10.5, call it plus another 3, so call it 14 because it's 3.5, plus today's video of 3 hours, that is 17 hours. We have covered the fundamentals or the basics, let's say, of Python in 17 hours. So congrats if you made it this far. I'm excited to carry on this journey, and I'll have something special for you guys tomorrow for the next video. So stay tuned, like, subscribe, and thank you for supporting the channel.